Hi, my name is Yuriko. I'm from Group 19, and today we will be explaining about our implementation section of our group control project. My colleague Harsh and Christopher will be explaining about the FTL and the main functions, and along with the movement functions, while I will be explaining about the advanced objective in the next video.
Hi, I'm going to explain the movement function. Our movement function has four parameters: time, direction, left motor speed, and right motor speed. Here we're setting up the PWM period and the duty cycle by writing to the respective registers. As we know, our robot uses 10-bit PWM motors, which are controlled by a dual H bridge motor that requires 3 signals to control the speed and direction. 2 bits are for the direction and 1 bit for the PWM signal. Here we have initialized the left and right motors using those 2 bits, 0 and 1. So moving forward, going backward, and while stopping, all of them will be 0. In this for loop here, the loop keeps iterating until it reaches the time we initialized in our function. So it will keep going forward, and when the direction is 0. Here we stop all the motors so that it's just another form of delay, so that it can move to the next function. Coming to the main, we have called the FTL function so that the robot can move in the outer track twice for 2 laps, and then it needs to move to the inner track. And to do that, we're using the movement function. So as mentioned previously, this is the time, the direction, the left motor speed, and the right motor speed. In order to move to the right, the left motor speed must be greater than the right. So it does this for 550 milliseconds, and then both the left and right motor speeds are the same, so it will keep moving forward for 600 milliseconds, and then in order to align itself to the inner track, it will move to the left again by increasing the right motor speed for 500 milliseconds. It will then move, we then call the FTL function again to move to the white line, stop there for 5 seconds, and do the 180 turn, go around the inner track for a lap, and then it needs to move outside, and we use the movement function. So again, the left motor speed is greater so that it can turn to the right 550 milliseconds, move forward for 600 milliseconds, and turn to the left again by increasing the right motor speed. It then goes to stopping point. We use the FTL function, and as per the system requirements, the LEDs need to flash for 5 seconds before and after.
So moving on to the FTL function, which is following the line. It has loop count for how many laps the robot has completed around the outer track and inner tracks. The gain multiplier is represented by K. Max speed is the desired speed in 10-bit scale. Offset is to avoid double reading the line. OFL and OFR are used to control the speed of the left side and right side of the motor respectively. Loop 2 is the loop count for how many laps the robot have done. For this section is the advanced objective, which will be explained by my friends later on. Following the code for FTLs, the SparkFun sensor inputs use the I2C code below. The following statement is used for initializing to start the motor. This following if cases is used to determine the input value of the SparkFun sensor. The line sensor or the line sensor variable are used to validate the data from sensor inputs, which will be converted to the binary by using 0B in front of its input. The error is the amount of degree the robot must rectify in order to continue following the line. For these else-if cases, all the sensor intersected the white line during this time. It will add 1 to loop 2, which indicate that the robot has completed a lapse. The moving functions is used here to eliminate the possibility of detecting the white line twice by using the offset. This following code is to start the motor function. U is the motor speed which the robot used to fix itself if it went out of the line. So by this we will use arrow times the gain. MS speed is the speed decided by the obstacle sensor minus the speed of the sensor, speed of the motor determined by the line sensor. Mach space R and mach space L is the final speed the robot will use for following the line. Lastly, this code is to stop the motor after the following the line, and that's all for following the line.